This is Algebra 1, Term 5, Lesson 10, Equations and Models. First, we'll do a Desmos activity where students will use algebra tiles in a variety of ways. Then we'll do GeoGebra models, where we'll create algebra tile models for equations and solve. And then finally, we're going to go outside and do a little sidewalk chalk. So let's get started with Desmos. So the bulk of your time will be spent in this Desmos activity, and students will learn how to model expressions and equations using algebra tiles, and then we'll progress to solving equations with algebra tiles. When they come into the first screen, they're just basically going to start dragging tiles up here, and as they do, the expression here on the right will change. So hopefully they see what's happening as they bring in these expressions. See, that's changing. Tell them to bring a whole bunch of tiles in and just keep watching that expression as they do, and then they'll be able to type here something they notice and something that they wonder. Now once they've made sense of that, they should then be able to go to this model and create a polynomial. This is a trinomial, and they're just typing it in the box. These are self-checking. They are being asked also to classify the result. So some of these answers are going to be linear, quadratic, binomials, trinomials. And so this is an opportunity to review some vocabulary. Here they're going to type an expression for this model, but this time they do want to combine like terms. So that's something you could talk about if they are unsure what that means. And then a similar tile model. Now all of these problems are technically not in the Algebra 1 curriculum. The students would have been exposed to simplifying expressions, solving linear equations. This is all basically review. But what I've discovered in algebra is that a lot of kids know how to do these things, but they don't know why things work the way that they do. And so these models help students get their mind wrapped around the concepts that they are actually doing, you know, the actual inverse operations and why things are the way they are. So some of us that are teaching do not realize that our kids don't really know what they're doing if they're getting right answers. We think they're getting it, but unfortunately, through my experience, that's not true. They can get a lot of right answers and have no clue why it's working. And they'll even tell you, I don't know why it works, but this is the answer. And I'm like, well, if you don't know why it works, then I don't really care about the answer. So in this case, they're going to combine like terms again and write an expression, and then they will again classify their result. Now in this part, they're going to drag these onto this mat. There is no expression given, so they're not going to be able to check this one. You'll have to help them or check it yourself manually. And then you may ask them, is there more than one way to build this? Well, if they put in some zero pairs, they could actually build this an infinite number of ways. So you might encourage that and see if you can get them to build several different models for this exact same expression. And then we're going to build another model. This time we're using the distributive property. So you might want to check to make sure that they are distributing that 3. Now here's an equation. At first they're just going to play with this and see if they can figure out a way to get this solution. A lot of the kids are going to know how to find the value of x, and they will get it right away. But the question is, can you make this model do something? Can you use it in some way to show that the value of x is what you say it is? So let them play. I would definitely pace your students so that they're not going past screen 7 until this is done. So give every kid an opportunity to play, to manipulate these tiles. So you see they can move these around. So what do you do to both sides of this equation if you're solving? And so they could actually try to do what they're saying with those tiles. And then we'll go to the next screen. Now this cool problem, I've never seen anything quite like it, actually works the problem while this video is playing. And I'm not a big fan of doing this type of direct instruction, but in this case it's super powerful to have those expressions popping up along with the model in the video. Now this model doesn't change over here unless the students change it. So I encourage them in their instructions to follow along by using the algebra tiles. So they are going to actually do here what he's doing over here, and then watch as these expressions appear, or the equations appear, as he's working. Very interesting. And it shows how the algebra tiles are very powerful in helping them model what they're actually doing. And then they're going to use a similar strategy to solve this equation with algebra tiles. So it says to use the tile model to solve. So they should be doing something with those tiles as they are working along. So in this screen, we're going to have a conversation. How should we approach solving this with a negative coefficient? How in the world are we going to use these tiles to represent that? Let the kids talk about it. Most of the kids are going to know how to get the solution to the equation, but the question is, can you figure out a way to model that with these algebra tiles? I will give you some suggestions in your teacher notes, but let them talk about it. They may have some good ideas about ways they could represent this equation and make it easier maybe to solve with the algebra tiles. Okay, here they have two different expressions, one from Felipe and another from Isabel, and they are deciding who is correct, or maybe they're both correct, or maybe they're both incorrect. So have a conversation about this tile model and these two equations. And then for the remaining 3 slides, they are actually going to create their own model for an equation. So they will drag these down, so these move, these tiles. They're going to drag them into the mat. The left side of the equation should appear on the left side of the mat. And the right side of the equation will appear on the right side of the mat. And I really love this because it gets kids to think about these quantities they're seeing in the equation and how those are represented with the tiles. So they're practicing modeling, and then they're going to solve the equation and after they've checked their model. So it will tell them if they're right, and then it'll say solve it, find the value of x, and type the solution. Now they should use the tiles to do it. It says balanced, and that's a way of keeping track of what they're doing. If it doesn't say balanced, then they've got an error, like in their process. So they could use the tiles and go along with their solving strategies. I usually have them write out on whiteboards or paper as they're working these to show what they're doing. You could even take up the paper if you want to make sure they're writing these down or doing these step by step. Okay, another model. This time we have the distributive property. Is there more than one way to solve this? Could you distribute first, divide first? What could you do? So have them talk about that as they're solving on this one. And then finally, we're going to do this one. Now, this one does come into a little bit of an issue at the end because you're dividing and you don't have an even number of tiles. So even though you can't really show it exactly, talk about how that might be represented with the tiles. And this concludes our Desmos activity. Next, we'll head back to slides. In your slides, you're going to be given an equation, and students will go to GeoGebra and they will model this equation with algebra tiles. When they go to GeoGebra, it's going to look like this. So first thing you'll do is click on the drop-down menu at the top left corner, and they're going to choose Equations Mat. And that's going to give them 2 areas with an equal sign. And then they'll model by putting their X's in. These are the X's. I usually have them all go the same way. So you could have them horizontal or vertical. Doesn't matter. And then their 1s. They might have some negative 1s, but they're just going to drag these into space. I'm not giving you the one that's on their slide, but they will do that, and then they'll screen capture this model, and they'll put a picture on the slide for their original problem, and then as they're working, like each step of the way, they could take a picture for each step of the process they used to solve, and they'll put those pictures on there too. They can shrink them down to as tiny as they need to, so just grab the corner of the image and drag it in. They know how to do that. They do it all the time, so have them just get it on that slide however they want and arrange it in a way that makes sense. They can also shrink the directions on the slide if that's necessary to give them more space to work. They will insert screenshots with descriptions of properties and operations used. My suggestion is they write on a mini whiteboard and kind of describe the process as they're solving on the whiteboard, and then they can just insert their tile model pictures. But they can do it however they want. There are tools in slides that they can insert text and explanations right here on the slide. When they go to the next slide, same thing, different equation, same process. When they get to the third one, we're kind of going in reverse. I'm giving them a tile model, and they're going to create an equation that will match it, and then they will solve that equation and capture screenshots of their model as they go through this problem. They will also describe the properties and the operations they're using as they are solving. And the same here. Now, something you might notice on this third model is they could technically use a distributed property here if they wanted to for the left side. Encourage conversations about these type things. If students come up with multiple ways to represent these models, that's fantastic. That's what we want. We want flexible thinking, and we want kids to be able to recognize different ways of representing the same model. Now that we're through with the GeoGebra task, the fun starts. We're going to go outside and we're going to do a problem on the sidewalk. My recommendation for my classes is always to do it on paper first, so they create their own equation, they create their own tile model, they solve the equation showing their process with the tiles and using their equation, and they put all of that work on the sidewalk. They will insert a picture of their sidewalk chalk and they will place it on the screen. This is an example of something that would be great for a portfolio. And so I do have some examples of my own students who have done this, and I will be putting those examples in the teacher slides. So if you do get a copy of this curriculum, the full curriculum, then you will have access to those student work samples. And they're kind of interesting. They're fun. I do these every year, and they always ask me, why do we have to put it on the sidewalk? I go, well, honestly, it's so we can go outside and have fun. So it's really just more of a brain break than it is algebra. But you know, it's that time of year. We're getting close to the end of school. We're getting close to the end of the 5th term, and I don't know when y'all spring break is, but usually this is right around there, maybe right after that. Kids are antsy. They're ready to move around and do some other things. So this is a fun activity. And that concludes our equations and models lesson. Y'all have a great day.